Hello everyone, welcome back to my YouTube channel. Today we have a very important topic before us, the quadratic function. As we all know, this is the quadratic function. Okay, now from this, what we want to try to do today, what I want to show you today is how you can obtain from this quadratic function the axis of symmetry of the function, and then of course the y-intercept. We all know that this is a parabola. Okay, it's a curve, it's a quadratic function that represents a certain curve. Okay, so in that curve we're going to see how to obtain the axis of symmetry and then the y-intercept. Now for us to do that, there's a need for us to convert from the standard form. This is the standard form. This is the standard form. There will be a need for us to convert from the standard form to the vertex form. And this is y equal to a bracket x plus h squared plus k. So we need to convert from the standard form to the vertex form. Now, this h and k, h will represent a certain value and k will also represent a certain value. So from the value of h, whatever h gives us, we will be able to determine the axis of symmetry from h. And then of course, we want to be able to determine the value of h will tell us what the axis of symmetry will be, and then the value of k will tell us what the y-intercept will be. And for us to do that, we are going to be able, to convert from the standard form to the vertex form. There will be need for us to apply the principle of completing the square method. Okay, so without wasting much time, let's begin. But before then, please, if today is your first time of coming across my YouTube channel, please endeavor to subscribe to my channel, turn on the notification button, and then give me a like. Thank you very much. Okay, so we have to now start by looking at the function itself. The function is y equal to ax squared plus bx plus c. Now the first thing I will do is to isolate the variables, the terms with variable x. And the way to do that is to isolate the terms with variable x from the constant. Okay, we have ax squared plus bx. That's variable, the terms with a variable x. So the next thing is to I want to factorize a out. I'll bring out the a, and then once I bring out the a, in the bracket I'm going to have x squared plus. Since I've brought out the a, how did I get the x squared? I divide ax squared by the a. Okay, the same thing I'm going to do. I have bx here. I'm going to divide bx by a, and that will give me bx over a, then plus c. So I'm still going to go ahead and rewrite the function within the bracket to give a bracket x squared plus, so I'm going to write it in such a way that I have the constant, the coefficient of x separate, b over ax, close the bracket, plus c. Now, so there's something we are going to do with the coefficient of x. You can look at it that x squared is standing on alone, and then the coefficient of x is b over a. There's something we need to do with it. So what we're going to do, in order for us to apply the completing the square, we are going to, because if you look at it, this expression in brackets is an incomplete square. So we need to complete the square. How do we do that? We look at the coefficient of x. The coefficient of x here is b over a. Coefficient of x. B over a. Then the next thing is to divide the coefficient of x by 2. Meaning, let's find half of it. Half of b over a. That will give us half times b over a. 1 times b will give us b, and 2 times a will give us 2a. The next thing we need to do here is to take the square of this half of b over a. Take the square of it. So once we take the square of b over a, b over 2a, that will be b over 2a squared. So what do? This is the function, this is the term we are looking for, the value we are looking for, the value that we are going to use to complete the square. Now, how do we complete the square? So what we are going to do now is we are going to add this, we are going to put in this term into these brackets. Not only are we going to add, because you know whatever you do normally, this is a function with 2 sides. We have the side on the left and the side on the right. So normally we are supposed to add this term. You add it on this side, okay, and then you also add it on the other side. So whatever you do to the right must be done to the left. But because we are actually solving for y, the function, what we are going to do is to add and subtract this term to the right hand side, and not just to the right hand side, it has to be within the parentheses or the brackets. Okay, so what I'm going to do now is to say add and subtract b over 2a squared to the terms in the bracket. I hope that is clear. Add and subtract. So once we add and subtract, so the function becomes y equal to a, open the bracket, s squared plus b over ax. Now we are going to introduce this term. And because we are introducing this term that has a bracket already, so we are going to use a separate bracket, a different kind of bracket. So I'll use a square bracket, okay, to indicate that the 2 brackets are separate, okay. So now I used a square bracket. So now let us add b over 2a squared, and then also subtract it. Of course, once you add and subtract, it is 0. So you have b over 2a squared. You close the bracket, and then of course we have your c plus c. So next is that we are going to, inside this square bracket now, there are 2, we are going to group this term and this other term, and then use this a to open up we are going to use this a to open up this bracket. So once we do that, we are going to have y equal to a times x squared plus b over ax plus b over 2a squared. Sorry, I'm going to still maintain that square bracket. Okay, use the a to multiply this particular term that has square, and then of course use the same a to multiply minus a bracket b over 2a squared, then of course plus c. So now we are now going to factorize this. We put this is already a factor in factored form. So our y will be equal to a bracket. So what we just need to do is, because you know this is an expanded form, okay? So we want to shorten it. We just say x plus, you know I told you from the beginning that the expression is going to look like this. Okay, so it's going to be x plus b over 2a all squared. X plus b over 2a. Since from this x squared you pick an x, from the b over 2a squared you pick b over 2a, of course. Once you expand this, we are going to get back to this. Minus, this will be a times b squared over 4a then plus our c. So that is what is going to give us. You have a multiplied by b squared, that's ab squared. Then you have 2a squared, that will be 4a squared, then plus c. Okay, so we continue from here. So from that end, we are going to have y equal to a open bracket x plus b over 2a squared minus, okay, so what we need to do now is to say minus this a, we cancel one of the a's, so you have b over 4a plus c. So I'm going to rewrite this to look like b over 2a squared. Now I bring the c forward, so I have plus c minus b over 4a. So I'm going to find the LCM of this. Then that will be 4a. So once I find the LCM, this will be 4ac minus b squared rather. B squared, 4ac minus b squared. And of course, I write down my a bracket x plus b over 2a all squared. So this is the vertex form. This is the vertex form. I've been able to convert from the standard form to the vertex form. You can see clearly that this vertex form is synonymous, is similar to y equal to a bracket x plus h squared plus k. Now, in this case now, you will see that h will be equal to b over 2a, and then k will be equal to 4ac minus b squared over 4a. Now, from here, we are not done yet. We have just only found the value of h and then k. But there's something we need to do, which is actually what this particular video is all about. How do we find the axis of symmetry? Axis of symmetry. And then the y-intercept from this vertex form. How do we find axis of symmetry and the y-intercept from the vertex form? So I'll just come back here. Come over to this end here. Please, I want you to follow me. From our function, y equal to a open bracket x plus b over 2a squared plus 4ac minus b squared over 4a. Now, to find the axis of symmetry, we are going to set the term inside the bracket. Okay, to find the axis of symmetry, let's just say set the whole of this to be equal to 0. Okay, set the whole of this to be equal to 0. That's for the axis of symmetry. So to find the axis of symmetry, we say a open bracket x plus b over 2a squared equal to 0. And then when you divide both sides by a, we have that x plus b over 2a squared equal to 0. Because anything 0 divided by any number is 0. So what do we do next? Take the square roots. Take the square roots of both sides. Take the square roots of both sides. So once you take the square root of both sides, square root and square will cancel out each other. So we have x plus b over 2a equal to square root of 0 is 0. And now to find the value of x, simply move b over 2a to the other side. So that will be x equal to 0 minus b over 2a. So x is minus b over 2a. Now, for this function, for the quadratic function, converted to the vertex form from the standard form, the value of the axis of symmetry, the value of the axis of symmetry is minus b over 2a. Is minus b over 2a. It depends on if that's when the function is having a minimum value. If the function opens up in this form, then we have the axis of symmetry to be minus b over 2a. If the function looks this way, okay, then the axis of symmetry will be x equal to plus b over 2a. So in that case, the function will have a maximum value, where in this case here, the function has a minimum value. So now let's look at the y-intercept. How do we find the y-intercept? To find the y-intercept is simple. The y-intercept is simply the whole of this function, the constant. Okay? The constant here is the y-intercept. So the y-intercept will be 4ac minus b squared over 4a. That gives us the y-intercept of the function. This is where we end it. I'm going to make a follow-up video to this particular one, showing you how to apply this conversion from standard form to vertex form to find solve real practical problems in my next video. I will show you how to do that in my next video. Please subscribe, turn on the notification bell, and give me a like.